Let's discuss how a learning system or learning model can be designed. We have 5 steps which involves in designing a learning model. So before learning a model, these 5 steps should be properly adapted so that your model should be trained properly. So the first step is choosing the training experience, and second is choosing the target function, and the third step is representing the target function, and fourth one is function approximation algorithm should be chosen, and the fifth step is final design. So choosing the training experience is the first step in designing a learning model. So the learning model is going to take each and every sample and it is going to learn something from it. And once it is learned, it is going to be saved as whether it is a failure one or it is a successful insight which it has been learned from it. This largely impacts the model, the learning, the designing model's failure or success. So the control in which your failure or success of the model decides based on 3 attributes. One is feedback and degree control sequence, and the third one is example distribution. Let's see one by one in detail. So feedback, we have 2 types of feedback. One is direct feedback and the other one is indirect feedback. So the direct feedback is nothing but after identifying or classifying or predicting the outcome, the human is going to give directly feedback whether it is properly or correctly identified or not, whether the outcome is correct or not, whether the output is correct or not. That will be directly given from the human end. So this directly impacts your confidence scores of the training model. If it is a negative feedback, the confidence score is very low, and if it is a positive score, then obviously the confidence level of the model will be high. So for each and every misclassification or misprediction, the human will give certain feedbacks in order to make the corrections from the learning part. So if the feedback is indirect, it is nothing but your model is going to get evaluated using certain performance metrics like accuracy, recall, F measure. These are all certain matrices which is used to evaluate whether the model is properly working or not. So this is nothing but a validation set. And the second attribute is learning control over training examples. So after the training example have been fed into the model, so the active learning will be happening in the machine. Each and every time it is going to learn something from it, whether it is correct one or wrong one. Irrespective of that, from each and every success or failure, it is going to learn, and the information will be stored as a training experience for it. And the second thing is data augmentation in the training example. So if we are giving some features of a cat or a dog, for example, so in that case what happens, the degree in which you are providing the feature, that may be applied with the transformation. So the transformation may involve a rotation or any kind of scaling can be done. So after the rotation have been done or applied on the feature value, so the dog feature, if you are giving a tail of a dog, so in 360 degrees it may be applied, and changing the orientation, it is going to learn from that also, because if you give a different image as an input, it should identify properly from the learning. So it will learn after it applies the transformation on the values of each and every feature. And the third factor is distribution of examples. So whenever you are increasing the training samples, your learning will be going to be very high, and from that the accuracy will be increased. So if you want the performance to be efficient or the accuracy to be increased, then more training samples should be fed as an input to the training model, through which it will increase the experience of learning. So if we give a basket of fruits, then obviously all these factors will get into picture, and it will lead to the first step of designing a learning model. The second step is choosing the target function. So target function is nothing but the outcome, right? So if you want to move very closer to the outcome, then the learned experience should suggest you what should be the next move that you have to take. So that leads to success or failure. So if I'm giving you a basket of fruits and I want you to classify from that, then a classification function is nothing but it's a multi-class classification. It consists of so many fruits, so multi labels involved in it, multi outcome involved in it. So in such a way it should predict what kind of target function it focuses on while learning the model. The next move should be decided based on the function. And the third step is choosing representation for the target function. So this is nothing but the crucial move should be decided over here, which optimizes your move. This decides the outcome, whether the next move which you are deciding, that is going to give you whether the result will be a positive or negative, or it is correctly classified or wrongly classified. That will be relied only based on the next optimized move, that is the crucial move. You will be doing so many moves in that, which will be crucial, that should be decided by the representation of the target function. Here with respect to the basket of fruits, we have given a unique binary vector for each and every fruits. So we have specified three different apple, banana and orange. All this consists of a unique binary vector, and this representation will help to decide the crucial move while it tries to classify the fruit. The fourth step is choosing function approximation algorithm. So this helps in optimized move, and the given function is not actually enough for training the model. So the optimized move or the crucial move will not be happened with the training samples alone. So a set of samples should be properly identified, and more samples should be provided to the training model in order to approximate the chosen steps, which helps the machine to experience and to learn through feedbacks and increase the success rate of the classification or the prediction. So the final design is nothing but the number of examples which you have given for the model to learn from it, and how well it is trained, and which is the algorithm it is used for training the model. And the third factor is optimized moves. What all the optimized moves that it have to be taken in order to move towards success or failure. So all this together will decide your final design of the learning model. So whenever you are designing a learning model, you should give proper example for it. You have to first understand what is task, what is experience, and what is performance. So all this together will contribute to identify the task properly and to understand the problem statement. Once it is done, you have to provide enough number of examples for training the model, and then once it is trained based on the algorithm which we have given, the optimized steps will be taken into consideration in order to decide whether the given sample is success or failure. And then at last we will evaluate it through either positive feedback or negative feedback. So we have two kinds of feedbacks. One is direct feedback, the other one is indirect feedback, which helps to validate the training model. So this is how a learning model should be designed in machine learning. Thank you.